and I'll share that recording with you later on. Of course, feel free to ask any question when you have them. So I wanted to introduce tinyplot because it caught my attention. It's not something that I've used a lot, so I guess I wanted to do the presentation to learn more about it. And it looks very interesting. I think it is worth having a go at it. If you look at the website for tinyplots, this is how they introduce it. They call it a lightweight extension of the base R graphic system. Might close that. Which supports grouping, legends, facets, themes, and various other enhancements. So I guess the great thing about it is that it's kind of a modern take on base R plots. As you might already know, R has plotting functions out of the box, right? You could, for example, create a plot with the plot function, and then if I give it a vector of, say, 10 numbers, you will be happy to draw a plot of 10 points, right? With the index on the x-axis in this case. I just want to show the smallest example I know of a plot in R. And there's lots of different functions available, for example, bar plot or hist or histogram, etc. There's a lot of them and lots of visualizations useful for doing statistics in general. So it's great for a programming language to have that out of the box. You can create lots of interesting visualizations and look quite neat. But an issue with those functions, and that's often why people go to ggplot2, is that the way the functions are documented can be quite tricky in the names of the arguments. I'll show an example of that. And also, when you start customizing the plots, you end up spending a lot of time on getting it right. And the idea of tinyplot is that it is based on base R graphics. It is very lightweight, very small. And that's an issue with ggplot2. It relies on lots of other packages, right? If I look at ggplot2 on CRAN, it will show me all the things that it imports. And you can see that it does depend on quite a few other packages. There's a handful of them there that it needs to import to actually work, right? It is very useful. It does amazing things. It's very customizable, and a lot of other packages are built on top of it to create all sorts of visualizations, which is great. That's why a lot of people go straight to it. But if I look for tinyplot, can I do this? Maybe, yeah. If I look at tinyplot, it really relies on only packages that are already part of R, right? And that's why it's super lightweight. It's an extension of base R plotting functions, and it only relies on 5 packages that are already installed when you get R: graphics, graphic devices, stats, tools, and utils. That's really a very important aspect of it, and they try and stick to that to keep it as lightweight as possible. Now, for my examples, I'm going to use a data set called Penguins that is part of recent versions of R, quite useful to test things out. If you want to see the Penguins data set, you can do View Penguins. I zoom in once more, and it opens the little Viewer tab. You can explore the data, and it's about different species of penguins that have been observed on different islands. There's stats about bill characteristics and flipper length, body mass as well, sex of the penguin, and the year it was collected. It's a great little data set. And if I were to use a base R plotting function, I could use the general plot function to create a scatter plot. And I can refer straight away to the variable bill_len and flipper len. By using this formula notation with a tilde in the middle, it's one way of referring to the data, and then saying data equals penguins, because you have to say where it comes from. So it's looking at flipper length in relation to bill length, and it looks like there's somewhat a relationship there, which I guess makes sense. So that's the base R function. And to really see how much of an extension of base R plotting functions tinyplot is, it can be used as a drop-in. You can copy the exact same text or same code, but using the tinyplot package. So let's do the tinyplot equivalent of the same visualization. I'll have to load tinyplot, and if you don't have it already, of course, you can install it in packages here. Click on the install button and look for tinyplot. All lowercase, tinyplot, click install, and you'll get it. And then you'll be able to load the package with library tinyplot. And now I can copy that code to show you that it really is something that can replace base R plots very quickly. You can reuse the same code, and instead of the plot function, you're using the tinyplot function. And in this case, it gives me a different look. The reason for that is that I was playing with tinyplot before and I applied a theme. So what I might do is I might just restart R. I'll restart the session. Hopefully it removes my options. Yes, it does. So if you look at this base plot and this tinyplot and compare them, they're exactly the same one, right? So far, it doesn't look like tinyplot is useful for anything. It's exactly the same thing using exactly the same syntax. Now, for tinyplots, just before I move on, I want to say that you can use the alias PLT for short. Instead of typing tinyplot, if you want to save yourself a little bit of typing, you can use exactly the same syntax, but using PLT instead. So really, you could just remove the O from this bit of code, and you'll get the same thing. So that's the shorthand. But what, for example, it allows us to do is very quickly do some grouped visualization, which is not as easy in base R plots. So if I group it by species, I can do the same thing using the same formula, same data set. But here I'm going to use the vertical bar or the pipe to say grouped by species. So we extend the formula, and to group by something, we use the vertical bar and then add that extra variable. So now we get straight away the colored circles and the legend on the side. It would take a lot more effort in base plots to do that. That's the first kind of shortcut that tinyplot gives us. So it's pretty small to get to that point, which is nice. If you wanted the equivalent in base R, not in base R, but in ggplot2, you would do something like this. Oops. Load the library ggplot2, set up your defaults in ggplot. You've got your data set first. Then you've got your mapping of aesthetics. On the x-axis, we've got flipper len. I'm not sure if you can use a formula notation. I don't think you can use a formula notation in ggplot2. And then bill len. And finally, you'd use color equals species to do the grouping. Maybe I'll put it on a separate line here. That would be your setting up of defaults, the mapping of aesthetics. And after a plus sign, you can go to picking what kind of geometry you're using. And in our case, it would be probably a geom point. So it looks very different, but that's the same idea. You point to the data, you set up the x-axis, the y-axis, the grouping by color, and finally what kind of visualization it is. Base R and tinyplot by default will pick a point for two numeric variables. So it's a bit shorter, I guess, than ggplot2 to get to that point. But very importantly, a lot more lightweight when it comes to the package. Now, if I want to change the shapes for this plot, if you don't like the circles, welcome, Kim. If you don't like the circles, let's change the shape with PCH. And this is the first example of an argument that's not self-explanatory. When you see it for the first time, I don't even know actually what it stands for, to be honest. But PCH is an argument that is available in base R plotting, as well as tinyplot, that allows you to change the shape that you use for your points. So, for example, if we reuse that same bit of code, and then we've got the formula, we've got the data, but here we want to change the shape of our points to shape 20, for example. We get a smaller point and it's filled with the color. If you want to learn more about which shapes you've got access to, you can do question mark PCH, and it will bring up the information about it. If you scroll down, eventually you'll get to something visual here where you've got numbers that correspond to shapes, and also some extras here, although well, that's all of them, I think. There's 25 of them. And this you can do in base plots as well. You can do exactly the same syntax, the same argument. But what I wanted to show you is also, if you look at the documentation for the functions, right? You're creating a plot with a base R function, for example. If I look for the documentation for the plot function and go to the default scatterplot function, there will be a mention of PCH in there, a vector of plotting characters or symbols. It leads you to another page, but it's listed in the arguments, but it's not even shown in the syntax. If I look through here, yeah, it doesn't even show me, I think, PCH anywhere. And that's what I mean by the documentation for base plots being a little bit, well, fairly confusing, because a lot of it depends on the 3 dots at the end. These are extra arguments that are passed on to other functions. And that's probably where PCH would go. If you look at the tinyplot documentation instead, I find it a lot more informative. I'll go to usage and I will find PCH listed somewhere. Yeah, there it is. So it is in the syntax, and that makes it a lot more clearer that we can actually use it. And if I look through the documentation, eventually we'll get a longer form description of what it is. So it's the symbol to use, but it's also a character, which is interesting. You can use a character, any character you want, really, when you create a plot this. So for example, I'll show you, use any character. Using the same code as before, instead of PCH here, maybe I want a letter that shows that it's the species Adelie, Chinstrap, or Gentoo. I can give a vector here of 3 values and say the first one will be Oops. The first one will be A for Adderley. The second one will be C for Chinstrap. And the last one will be G for Gentoo. And now I use a letter for, so you could use also a dot if you want really something small. You could have a full stop as a character. You can use any character you want, really. So use the numbered symbols or use a character. And yeah, if you want, you can do an emoji as well. Let's see if that works. Yeah, I got lots of little, actually it just picks one of them. I get a little smiley face. Valerie looks like you think it's cool. So yeah, any character, I guess standard characters, and if it's part of Unicode, I think it should work. It's my assumption. Yeah. So that's changing the shape. Now, what if you want to change your color palettes? Let's reuse most of this. Actually, I'm going to keep the PCH to 20 because smaller points, it's quite handy to see things better. But here I'm going to go to changing the palette to something else. I'm going to say palette equals, for example, warm. There's a palette that's called warm. What's going on here? Let's see the results. Yeah, there you go, a different color palette. If you want to know what palettes are available, there's a couple of functions you can use to list the names of the palettes. You can do palette.pals, which is from graphic devices. It's from base R. If you run that without any argument, it gives you already 16 palette names that you can play with. And another one is HCL palettes or HCL pals, also from graphic devices. You can pick anything from here and you'll have in the list, I think, some color brewer palettes and some Viridis palettes as well. So there's a lot to choose from. You can play with those ones. You might find online some visual summaries of what they actually look like, but you can also test them as you go. So for example, you can change that to Mako as it's listed there, and it should work and give me something different. Dark 2, I think, is one. Yeah. So that's for palettes. And then we get into doing a bit of theming. So let's say we, again, reuse that. But I'll change a couple of settings. If I want a grid inside the plot, I can say grid equals true. That adds those faint lines, those dotted lines inside the plot. And also, if I want to remove the frame, I can set it to false. And so I don't have that rectangle around my plot. There's lots of options like this to directly theme your plot in there. But if you want to make things consistent, you can also set a theme for your whole session, like an option that you set once and then forget. Well, you don't have to repeat yourself inside the function. You can apply a persistent theme. And that's done with Tiny Theme. It's a very cute name, Tiny Theme. Pick the theme that you want. If you look at the documentation, you'll find which ones are already defined. If I set it to dark, for example, and then plot again the same thing, well, I don't have to use those last ones. I can even remove the color palettes because there might be also color palettes integrated already in the theme. So Tiny Theme Dark looks like this. If you need to have a visualization for something for a document that you've put in, let's say, dark mode, or a website that's in dark mode, Let's try a different one. There's one that's called clean 2. I've applied it, and now everything will use the same theme, which removes entirely those lines along the axis. So it's kind of like the minimal theme in ggplot2. Looks quite similar, but you'll notice that the color palette is different for these two because they're associated to the theme. Bring up the help page for Tiny Theme, and you'll see the different values that are available. There's quite a few to choose from, so hopefully there's something that works for you. The next thing I wanted to show you was faceting. Just like in ggplot2, you can apply faceting to your plot, so you've got subplots. So you can use, for example, a categorical variable, and for each level of that categorical variable, you get a subplot. So for our example here, we can still use bill length and flipper length colored by species with the penguin data. So this part here, actually we can keep also the PCH if we want, or we can use the circles. Let's stick to the circles. So same thing as before, same relationship, colored by species, but this time I'm going to go facet equals island, because in the data set there's the island column that tells us which island the data was collected on. And so I've got 3 islands and therefore 3 subplots, 3 facets. And it shows me that on the Torgerson island, there's only Adderley penguins. But that's a great way to represent yet another variable from your data set. If you're limited with the aesthetics, we call the aesthetics, here we use X and Y and color. We can put a 4th variable in there by splitting the visualization into subplots, into facets. Now we've looked at scatter plots. Here, there's lots of different visualization types in tinyplot. And the way to change that is to use a different type. So, for example, let's go to PLT. This time we're going to go straight to the tilde and then look at flipper length, because we're looking at the distribution of that, and then color that. Color that by species. The data still comes from penguins, but this time we change the type. Instead of the default scatter plot, we're going to go to a density plot. And I get those lines that show me the shape of the distribution. So we can see where most of the values of flipper length are for each species separately. You can change that to a field density plot. There's a side note, you can do fill equals by. And when you refer to by in tinyplot, it means which variable you've used for doing the grouping. So in this case, it's species. So it's a nice way to easily refer to the grouping variable. So now my visualization is filled up. The underneath of the curves is filled up with the color, which might be the look you're after. Now let's say we do the equivalent, but a histogram instead. Very similar kind of visualization to visualize the numeric variables distribution. Here I'm going to use exactly the same code, but I'm going to change the type to histogram instead. And I get something similar, a bit different because here you've got actual counts for your bins, for your bars, rather than density. But something that's very important to note here, and that's a difference with ggplot2, is that when you do a filled histogram in tinyplot, it does not stack the bars by default. And here we've got a filled histogram. It's not obvious, but if I remove this bit, if I only use type histogram and I don't fill by the grouping variable, you'll see what I mean. You've got this, automatically it's filled with a transparent color. And so you don't need to use that fill really. And it shows you that there is overlap on the bars. So it's not a stacked histogram. It is overlapping, which allows you to see the height of the bar, the orange bar here, for example, and know which value it corresponds to. But if you fill them up entirely with a solid color, it might be misleading, making you think that there's only a total of 21 for this particular bin, right? And there's lots of types available. Let's do another one here as an example. Hello.
Let's go August.
Oh yeah, August. Feel free to use. No, that's all good. So if I do a box plot, for example, there's a different kind of visualization. Let's do box plot. Let's do PLT on the bill length by species. If I find my characters. So I've got a numeric variable, bill length. I want to look at the distribution of this one, and I'm going to categorize it, or I'm going to use on an axis the species. All right. So once I've got my formula, I can go, of course, to data equals penguins to say where it comes from, and the type this time. Oops. And the type is box plot. And there's our box plot with our outliers. And for our last example, what I'm going to use, and I can bring up the help page for this one actually, to show you the different types that are available. I'll do search the documentation. Yes, it is detailed, but you do have to go through a fair bit to get to the point you're interested in. I'm going to go to the type argument and show you what you can do with it. You can use, again, it's a drop-in replacement for base plots. So you can use the shorthand that base plot allows, for example, for points, lines, combine points and lines. You can use those shortcuts, P, L, B, etc. You let tinyplot, if you don't give any type, tinyplot will use a sensible default, right? So before, when we were using the default, we were mainly using two numeric variables, so it picked scatterplot for us. But if I were to use, say, bill length and species, one numeric, one categorical, I could also let it choose the default that I think is the best. Right? If I run that, if I don't even say type equals box plot, it still picks a box plot because that would be the default categorical versus numerical continuous. But if I want to be specific, if I know what I want, I can also, of course, say types equals box plot. And then the other options that you have, they are tinyplot specific. You can use area, error bar, point range, polygon, polypath, rectangle, ribbon, segments, text, bar plot, box plot, density, histogram, jitter, QQ plot, ridge, rug, spine plot, violin. So there's a lot of options there. For example, the violin plot is a nice alternative to the box plot. let's replace boxplot with violin. You get this kind. And you can also use some models. So if we look at the relationship between two numeric variables, let's apply a linear model to it. I'm going to start with PLT. The formula that I'll use is, we'll go back to the bill length versus flipper length. The same example that we used before. Again, we'll use grouping by species to put some color in there. The data is still coming from penguins, but this time we'll use the type equals LM for linear model. And now you get a trend line on each of the populations, a straight line because it's linear, and you get that confidence interval around it as well. But this brings me to the last bit about this quick intro. How do you bring those points together with the fitted model? How do you layer several geometries like we do in ggplot2 using several geom functions? Let's have a look at that. So I'm going to reuse this bit here and use the default type to have a point or a scatter plot, right? But after this, and no need for a plus there because we're still in kind of base R plotting where we can modify plots by running extra functions. There is a function called tinyplot add, this one here, tinyplot add, but there's also the shorthand PLT add. And we can use the short version where we say, we only have to say type equals LN. That's the only thing that we change. It's the type of plot. And it adds our trend lines on top of our scatter plot. Right. So again, quite quick to put together, I think, a nice looking plot. We've applied a theme before that stays active during your session until you overwrite that. You've got your main function here that initiates your plot with the formula, x-axis, y-axis, grouping. Point to the right data set. Let tinyplot pick the right or the default most relevant kind of visualization for you. And then if you want to layer several ones, use PLT add to add an extra kind of visualization on top of it. That works also with faceting. You can do that with faceting. It handles it really well. And I'll stop here, but I really recommend having a look at the website. tinyplot, look up tinyplot. There's lots of great examples. There's a quick introduction, which is very similar to what I showed you just then. But if you go to the vignettes, you've got several articles and you've got a get started page. You'll have a lot more about the why and the how. It's really powerful, and it's definitely something that now that I've looked into it, definitely something that I will consider when, for example, create a Shiny application or creating a document that I want to put online, to make something that's as light as possible. Because again, ggplot2 brings in lots of dependencies. If I want to make something small, light, snappy, I'll see if maybe I want to use tinyplot as my visualization package for that, because it's a very nice in between, making things easier, and they look quite good as well with the themes, with a lot of flexibility, easier than base R, but still very light. And that's it for me. I'll take any question if there are. We can also move on to visualization in general if you've got questions, or if you want to recommend something that you've been using, feel free to. I'll stop the recording now.